spoke about, running experiments last week, and today's class is on analyzing this experiment, analyzing the data. Luckily, we have a lot of statistical tests. Also, luckily, there's a lot of software that can do them for you, so you don't have to do the math behind it. And I'm not going to show you, like I did before, all the math behind these. But there's math behind all of these tests. So you could do it manually, but you also have software like SPSS, SAS, R, where you can just plug it in and run the test, and it will tell you if there are statistical differences between these. And this is really good for analyzing experiments. So, for example, I have two groups, and I want to check if one is statistically different from another group. So here I'm comparing driving speed amongst athletes. I think football players will drive faster than basketball players. That's my hypothesis. Totally making this up. Now I can do a t-test. I can get this, so I can get their speeds, and then I can do a t-test, which will compare the speeds for let's say I did 100 football players, 100 basketball players, and I have the speed of all of them, and it will tell me, is there really a difference? Are they really higher? And this is very cool because sometimes you can have one person is higher, one person is lower, but it will compute the whole thing and tell you whether that is statistically different. Now, we have the same thing with analysis of variance in ANOVA, but the difference between a t-test and ANOVA is ANOVA you usually do for more than two groups. A t-test is only for two groups, but let's say I want to compare these football players, basketball players, and now soccer players too. So now I have three groups. The t-test won't work, so now I can do an ANOVA, which is similar, but it can do an additional group. Now, the chi-square compares this categorical data. I'll give you an example. So compare a coin, heads and tails. Is it equally likely to be heads and tails? Are zodiac signs evenly distributed across artists? Or do they fall into more common zodiac signs? So these categories, if you have like a number of categories, you would use chi-square. And I'm going to give more examples later as well. Correlation. So correlation is the one that's the most common. Like if you have these two linear lines and they go together. So here, hours of study, this is my hypothesis. Hours of study is positively correlated with test performance. I think the more people study, the better their performance, the better they'll do. Ear temperature is negatively correlated. So this is not positive, this is negative with the amount of clothing worn. I think the colder it is, the more layers you'll put on. The hotter it is, the higher your temperature goes, the less clothing we'll start wearing our t-shirts. So, like that's another correlation example. Rainfall is positively correlated with the amount of vegetation. The more rain, the more vegetation. So those are just some examples, and we'll give some more.